The topic for today's presentation is solenoid valve localization, feasibility and cost optimization. We belong to EEE Department of Vailtech High Tech Engineering College. The project was done by me, Rohini, and this is Ashwin Chitra. We undertook a project in WAPCO India Limited. Our project is based on air magnetic solenoid valves used in air braking in heavy vehicles. This is an air magnetic solenoid valve. There is a continuous supply of air at 8 to 6 bar pressure through this port. The solenoid valve works on the basis of electrical signals applied. Once an electrical signal is applied, a plunger gets attracted and air moves from the inlet port through the outlet port, pushes this piston out, and this hits the wheels of vehicles and brake is applied. On removing the electrical signal, the air from the inlet port moves to the delivery port. Our project was to localize this coil and produce a cost-effective solution for it. Traditionally, the coil was made up of copper. Our project was to replace this copper winding with aluminum and produce a cost-effective solution.
Good morning. Our abstract is solenoid valves are used in air braking system in heavy vehicles. The process of estimating the feasibility of an imported ABS solenoid valve and manufacturing locally, along with providing a solution for cost reduction in solenoid valves. Traditionally, the coil uses copper winded coils for producing the working flux for plunger attraction. The increase in price of copper motivate careful examination of approaches to minimize copper use. The cost of aluminum is lower than it might appear from the cost per unit mass of copper. The design details of a solenoid valve with aluminum wiring along with testing and performance results of aluminum air solenoid is depicted below. This is the process of our project: localization of ABS valve and cost optimization. Solenoid valve. Solenoid usually refers to a coil used to create magnetic fields when wrapped around a magnetic object or core. The coil is shaped such that the armature can be moved in and out of the center, altering the coil's inductance and thereby becoming an electromagnet. A solenoid valve is an electromechanical device that is used in air braking system in heavy vehicles. Parts and part function of a solenoid valve. Some of the parts are bobbin, coil, core, core tube, plunger and plunger spring. This is the expanded view of a solenoid valve. This is the core, exhaust post, bobbin, outer mold, supply wire given to the external supply, plunger spring connected to the plunger, inlet port which air is given to the inlet port, and outlet port is the delivery port, and this is the copper winding, that is the traditional winding. Localization process of an ABS valve. ABS solenoid valve. ABS valve is a 2x2 solenoid valve. Two valves are connected in an anti-parallel direction. One valve is normally closed valve and another is normally opened valve. The purpose of ABS valve is to prevent the wheels from locking. The process of dismantling. The outer mold is made up of nylon 6.6, which was scraped off using the lathe tools. This revealed the inner metallic supporting plate made up of stainless steel. It has two coils. One is white bobbin, another is red bobbin. This is the supporting plate. The coil consisted of a bobbin on which copper SWG34 wire was wound. Two colors of bobbins were used. Connection supply pins. One supply pin is taken from the red bobbin, another is from white bobbin, another is a interconnected supply pin. This is the bill of material. Some of the electrical specification of the ABS solenoid valve. This is the suggested modification, that is changing the winding material from copper to aluminum for cost optimization. Copper versus aluminum. Copper has higher thermal conductivity, higher heat transfer than aluminum. A comparison of properties of copper and aluminum. Process of choosing copper equivalent aluminum. These are the constant inputs given. Voltage is 24 volt, current 0.31 amps and resistance 74 to 80 ohms. SWG chart is the standard wire gauge chart which is used by all wire manufacturers. This is the sum of the formulas used for calculating parameters. These are the parameters calculated.
Solenoid valve testing. So once a solenoid valve is wound, it has to undergo a series of testing. The tests are as follows. The first one is a wire testing. The coil is wound and heated to 220 degrees Celsius for about 30 minutes to check the strength of the enamel used. Apply 8 bar pressure by opening a 3-way valve. This is a performance testing. The valve delivers air pressure and the air cylinder is actuated on the application of 24 volt. The piston rod moves out. Remove the applied voltage and the air pressure is exhausted. The piston rod moves in. This is a figure of the testing rig. On leak test. Once a valve is on, there should be no leak at the exhaust valve. For off leak test, the output should come through the exhaust valve. These are the specifications for pickup voltage and release voltage. The valve should not get actuated at 11.5 volt at 8 bar pressure. The release voltage should not be less than 2 volt. This is the endurance testing. The coil is heated for 6 hours and the resistance should not exceed more than 175 ohm. For continuous on test, the coil is heated for 24 hours at 32 volt at 80 degrees Celsius. The formula used to calculate the variation of resistance is given by RT is equal to R0 into 1 plus alpha T, where alpha is the coefficient of resistance. This is the stroke length test and this is a testing rig. The variation of force voltage is shown in a graph here. The solenoid valve should have a 100% duty cycle. This is a graph that depicts the characteristics of copper and aluminium. This is the cost calculation. The cost saving details is a single coil uses 14.6 rupees of copper, whereas aluminium is only 2.874 rupees, so a total of 1.48 crores is obtained. This is a conclusion. Our paper was published in an international conference and we got the best paper award, and this is a certificate verification for it. So thus by replacing copper to aluminium, cost-effective solution of 1.48 crores was obtained. Thank you.
Thank you.